All right, I had somebody else ask about problem 13, and they were kind enough to even give us the desired substitution there, that 3x equals 2 cosine u. So that's really nice of them. So 3x equals 2 cosine u. So that means that if I take the derivative, 3 dx equals negative 2 sine u du. And we are trying to substitute in for x. So I'm going to divide by 3. So I have negative 2/3 sine u du. So I'm going to substitute in. I'll rewrite my integration here. So instead of writing 4 minus 9x squared like that, recognizing that 9x squared is really 3x inside of parentheses squared dx, then bringing that up here so we can rewrite it as the square root of 4 minus, we substituted 3x equals 2 cosine u. So we have 4 cosine squared u. And we found that dx equals negative 2/3 sine u du. So we're going to multiply this by negative 2/3. I'm just going to squeeze it down a line, sine u du. All right, here's a nice thing. The terms inside of the square root have a 4 in common. The square root of 4 is 2. So I can actually pull that out in front of the integrand. I'm going to combine the 2 with the 2/3 to be negative 4/3 integral of 1 minus cosine squared u sine u du. Here's another nice thing. We know for all triangles forever that sine squared of u plus cosine squared of u equals 1. And this means that if we do 1 minus cosine squared u, it's sine squared u. Sine squared u equals 1 minus cosine squared u, which we can use then to substitute this piece right here is really just another version of sine. So we have negative 4/3 times the integral of sine squared u du, like that. That's great. Okay, so what we need to do now is figure out how to use sine squared u du. What I really suggest that when you're working on these sorts of problems, that you have your IB formula sheet on the side. Because there's an IB formula that'll be really helpful when you deal with sine squared u. Let's pull up that IB formula booklet. When I look at the IB formula booklet, and I'm looking in the trigonometry section right now because I'm trying to deal with something with sine. And let's see, trigonometry, I see on the trigonometry that sine squared u, there we are. Where are you? Yeah. So right there at the top of page 7, there's a double angle identity, which allows you to rewrite sine squared u. The double angle identity says that, let me write it in a different color. The double angle identity says that cosine of 2 theta equals 1 minus 2 sine squared theta. And so I'm just going to rearrange that and use that to do my integral. Negative 4/3 integral of cosine 2 theta minus 1 over negative 2 du. And then what we can do is just integrate that. So I'll pull the negative 2 in front to give me 2/3 in front. And then the integral of cosine of 2 theta would be sine of 2 theta over 2. And the integral of 1 would just be, I shouldn't have used theta. I should have used the letter u. So cosine of 2u over 2 minus u. And then the very last thing to do is to un-u it, because the question came in terms of x. So I'll just take that same value there, and I know that u is related from this original equation, so that u is equal to the arc cosine of 3x over 2. And so the last piece is just taking that right down into there and down into there. Okay? I'm not going to worry about simplifying it at this time, but there is a way you could do it. Drawing the triangle can have a really nice simplification there. But I'm out of time for today. Feel free to ask for more videos, and I'll throw them up there.